This is Darren Marchant with American Nomad News. In the last couple of segments, we talked about lettuce and grapevines, and we even touched a little bit on aquaponics and tilapia and turtles and these kinds of things. In this episode, I'd like to talk about scale. Now, vines and tilapia and lettuce are fairly small units. A tilapia can be about this big, lettuce about this big, vines, they spread out, but they're not that large of a plant. But in microgravity, especially in a tessellated station on the scale of miles, with the tessellations being, 3 meters on a side, large plants can be grown in there, and there may be big advantages in growing some of these very large plants. Bamboo is a good candidate because it can sequester toxins. If you have portions of your astroponics that you're seeing certain things show up, you can grow certain plants that tend to absorb heavy metals or those kinds of things, encapsulate them in such a way that you don't have to release them back into the environment. Bamboo is a candidate for construction materials. You can make some of your smaller subtessellations of triangles or squares or whatever you want, or wall battings and stuff out of bamboo. You can make flooring and stuff in your home environments at 1G. Some of the flooring can be hardwood bamboo flooring. And that hardwood bamboo flooring, just go to your local flooring store and go look at hardwood bamboo flooring. It's beautiful. It's got an absolutely fantastic wear rating, and it can be industrially manufactured quite easily. So bamboo's a good candidate. It can be taken up from earth in just little sprouts. And when you get on the station, they can be grown to very large size, converting CO2 to oxygen and sequestered woody products. Medication. Helps me with my heartburn. Okay. So, I don't always get heartburn, but when I do, it's because of my diet. And I've been, not paying as much attention to what I should eat. Now, other large plants that are very popular can be apple trees. Apple trees could be lots of fun. Coconut, pecan. These kinds of plants are very large and may grow in very unusual ways in microgravity. It'd be interesting to see how the roots respond to essentially an aeroponic environment where you enclose the roots in something that shields them from the light but allows the moisture and air to blow through on a regular basis. And you may have to have heavier attachment, tying them off to the main struts with more lashing and that kind of thing to keep them from bouncing around. Or you may just like being able to move them. They may be more bushy, or they may be inclined to grow long and straight if you arrange your lights and your other trees in such a way to encourage the directional growth of the branches. The fruit falling off and moving around in the air may influence how fast you want that air moving at different times of production. Now, coconuts, they produce year-round, and coconuts, they're pretty big. So when them suckers pop off, you may want to just plan for it and design your air movement and the environment such that the coconuts simply fall off, hit a gradient, and roll along that gradient by airflow to a catch area, and you just go over and pick them up. So they go to a central spot. It might actually work out really good. Coconuts are great. The shell has been made into different materials. The husk is good for, if you compost it, can be really nice medium for other growing materials. You can stuff it into your quilted, composted quilted medium for growing your lettuce and your grapes and things. The trunk, unfortunately, of coconut is not super impressive for its strength or rigidity or any of this kind of thing, because it's really porous, super, low density, short fiber length, all that kind of thing. You might have some fun with impregnating dried out coconut trunks with resin, but that's a lot of work, and it doesn't really produce an industrial product. Chipper shredding that and using it and composting it into something you use for bedding material or something like that may end up being a better use for it. Now, apple makes a nice wood. It can be used for smoking the tilapia or chickens. That might be a good idea. The apples themselves, everybody knows what to do with apples. All the different recipes and the lovely different varieties that are available could easily be shipped up to orbit in form of either the raw apples or just the seeds in packets. Makes for easy transport, and once you get them up there and you start adding the elemental materials, the plants and the animals start turning them into more familiar materials, kind of like we do from the air we breathe and the soil in the ground. The apple tree turns that into an apple, and isn't that lovely? Pecans, another good source of lumber. The leaves in these trees compost well, just like the apples and the coconut leaves. Once they're now, the coconut leaves, you might want to shred those up, or you might find some fun uses for them in your station. Pecan, also like that. Now, hardwoods like oak or Osage orange, these don't have edible fruits, and yet you may choose to have some of them because of the incredible lumber that you can get out of them. And yet bamboo has an edible component in the shoots and makes a very good engineered lumber. So there's a lot of things to consider with those. Building these structures gives a tremendous amount of flexibility in what you can produce. Potatoes have been produced hydroponically and aquaponically, and it turns out, and their videos are really cool. You just pick them whenever you want them, put the plant back, they grow more potatoes. Because you don't have to dig them out of the soil and disturb the plant. You can just reach in and pick them out. A lot of different varieties of potatoes out there, and it would be just as easy to bring a variety of potatoes with, as opposed to just having one, just bakers or something. Carrots. Carrots are an interesting one. I'm curious to see how they grow in microgravity. If you may decide with something like carrots that you want it to grow in a heavier density medium. So your quilted mediums that you plant your carrots in may have some soil that is post-processed from asteroid mining. So you take out the heavy metals and the different things that you want, and the tailings from asteroid mining, you test your tailings to see, is this tailings appropriate to use as a soil base for the gardening. It may have that you find a batch that has some nitrogen in it or some potassium, and you add that a little bit into the mix. You may find that you burn some of your carbon materials and use that to make potash and things like that. And yes, in a station this large, you could totally get away with burning fires, and in a certain scale, under controlled conditions, yeah, it worked fine. You can smoke fish in space. Not on the International Space Station. Oh no, that would not work. No. Well, okay, technically somebody could build a gadget to do the thing on a very, very small scale. It would be a serious pain in the katukas. But on the kind of station that would be on a permanent rotating cycler, like the Aldrin cycler, going back and forth from Earth to Mars, as was discussed in another video, yeah, you could totally smoke fish. Now, tilapia is one thing, but we like stuff like salmon. Now, trout is a good alternative to salmon because it grows only in fresh water, and they're fairly tolerant of captive conditions because we grow them all the time and stock people's lakes with them, like lakes and ponds and rivers and stuff. Trout smoked trout could work out pretty good as an alternative to smoked salmon. They are a similar species. I'm pretty sure they're related. But salmon, if you could pull off salmon, you would impress some people with that one. So some folks might be out there going, okay, how can we figure out how to do a saltwater fish like salmon in this very large multi-G kind of environment? You may find that a full G isn't entirely necessary for aquatics, and so that may help your engineering. But spinning large bodies of water increases the engineering requirements through the roof. And we're not even talking about station dynamics yet. We'll get into that later. Station dynamics would have to do with things like sympathetic motion and load and vibration and these kinds of things. So we're not even into that just yet. Just a little touch on it. But these issues can be a pretty big deal. They really can. So salmon might be one of those that takes a long time for people to get around to doing, especially as the station is smaller. Now remember, this is a note. Put a note. This type of station is intended to be scalable. That is to say, it grows cellular. Your tessellations can be added continuously. You may even get to the point where your station is so large that you want to split it in half and begin separation of the two parts, migrate personnel so that you have a duplication of specialties on both sides and a duplication of equipment, propulsion, life support, centrifugal systems, and so forth, separated out, a mitosis. On the solar system scale, you look at this, it would look like two cells. That's why I say mitosis. It's quite fascinating. I just grin when I think about that stuff. I like it. So these plants can separate, these processing vessels can separate at a certain point, and each continue to grow to the point where they get big enough that they can do it again. And you can have multiple cyclers going at the same time, and they can go between multiple planets, right? So they can migrate all over the system, and the humans can jump from one to another, to planets, to asteroids, to whatever. So yeah, astroponics gets very exciting. Thank you very much for tuning in. I'm getting up to about 15 minutes on the video here, and that's kind of how I like to keep them. And I hope to see your comments and your interest in this. Please join me again. Like, subscribe, hit the bell. God bless.